Hi, my name's Weiman Kwan, creator of the WMK Math channel. In this video, I'm going to talk about translating words into equations. Here are the following things I will investigate in this video. First, I will be talking about identifying variables in a statement. Secondly, I will be talking about translating keywords into mathematical symbols. Finally, I will be talking about how to translate any word statements into an equation. Now, before we actually start talking about translating statements into math equations, we got to talk about one thing, and that is, what is a variable? So what is a variable? A variable, you can think of it as some unknown quantity which may or may not be the same number. For example, think of something that is not always the same. What could they be? Here are some good examples. Time, sometimes in minutes, sometimes in seconds. Cost, usually in dollars. And number of things, like number of apples, number of oranges. These are all considered to be variables. Now, variables are usually represented by some sort of letter in mathematics. We usually use x and y. For example, we could say x is the number of apples. Now, what happens if we have two variables in play? Say we have number of apples and number of oranges. How do you represent them? Well, these two are completely different things. So if we have two different things, we have to use two different variables. So we can say x is the number of apples and y is the number of oranges. Now what happens if we represent both of them with the same variable? That means that apples are the same as oranges, which is not true. So if they're two separate things, you got to represent them with two separate variables. Now let's start taking a look at mathematical statements. We have this statement here. George's age is the same as Mila's age. What are the variables in this statement? In this case, there are actually two variables. There's George's age and Mila's age. One person might ask, but they're both ages. Aren't they the same? To an untrained eye, it might seem like they're the same thing because age is the same as age. However, in this particular case, they are actually referring to two different persons. So George's age is one variable. Mila's age is another variable. And they're two separate variables because they're not the same person. They're two different entities. That's why they're separated as two variables. In equation statements, these two variables are associated in some sort of way. So normally in a statement, when you're saying, after we identify the variables, how are they related to one another? So we have the variables highlighted in blue. How are they linked together? In this case, I'm going to use George as x, Mila as y, just because I like x and y. I could use g and m if I wanted to, but I've decided to use x and y because it's the easier thing. But how are they linked together? We have this statement in green. Is the same as. This is the linking statement between George's age and Mila's age, in which we have x and in some way associated with y. But how? What the heck does is the same as means? This is where we're going to have to use some sort of dictionary or mathematics translation dictionary. And we'll start with some of the basic translations. So, if you see the word is, when you see is in the statement, so variable 1, variable 2, and then is means equal sign. The same as, it's basically the same as an equal sign. So if you see the same as, you literally do nothing, especially when you combine these two. Now we have an understanding of is the same as. Let's go back to our previous statement. Is the same as is literally equal sign. So we could write the statement as x equals y. And this is our mathematical equation representing this statement. Now let's take a look at other possible translations that we could encounter when translating words into equations. Now, this is not the only thing. There are others. So, one of the others is probably all the other math operators that you've encountered. For example, whenever you see more than, it usually refers to plus. Example, 4 more than, so it's plus 4. Whenever you see less than, it means minus. For example, 3 less than means minus 3. Finally, whenever you see times, it literally means time. So 3 times, so 3 times something. So that's page number 1. Here are some possible other translations that you may encounter when doing equation translation. So, whenever you see twice as much or double, it literally means 2 times something. In this case, I'm going to use x to represent that something as a dummy variable to better understand what this statement means. So when you see twice as much or double, it means 2 times. Whenever you see half as much, it literally means half times. Or you could use x divided by 2. They both represent the same thing here. If you see 3 times as much or triple, it means 3 times something. Similarly, if you see a third of, it's a third times x, or you could use x divided by 3. Finally, whenever you see some of these buzzwords, sum, difference, product, and quotient, sum means addition, difference means subtraction, product means multiplication, quotient means division. Now, I've given you a huge list of possible translations. Are these the only things that are possible? Absolutely not. There are probably countless other ways of writing some different operations. Now, these are kind of like the basics to get us started in really starting to understand how we can translate statements into an equation. Now, what is the process of actually translating the words into equations? We have 4 simple steps to get you started. So the first step is, anytime you read a statement, first you got to read the statement. That's step 0. Step 1 is to identify the variables in the statement. So you highlight them, and then you choose a letter to represent these variables. The second step is, we got to identify the word statements linking these variables, and then we translate these words into math symbols. Finally, we write the equation. And this concludes our process of getting some statement into some variable, an equation. Let's take a look at our first example. The cost of apples is 3 less the cost of oranges. First question, what are the variables in this statement? We actually have two. The cost of apples, which I'm going to represent them as X, and the cost of oranges, which I'm going to represent them by Y. First, after that, let's identify our linking statement. In this case, it is 3 less than. Now, how do we translate this? We look back at our dictionary and we see some of our buzzwords. Is means equal signs. Less than means -3. Or actually minus. And we have a 3 in front, so it's 3 less than means -3. Then we kind of combine all of our words into some sort of statements. Notice that we have -3 and then we have Y. Whenever you're separated by these, you can assume that there's an addition. So we have it's plus Y. Now this comes to the conclusion of our statement X equals to Y minus 3. Alternatively, your equation could also be X equals to -3 plus Y. They both mean the same thing in this case. Now, let's take a look at our second example. The number of toys in box 1 is twice the number of toys in box 2. So, what are our variables here? There are actually two variables. Number of toys in box 1 and number of toys in box 2. Are they even the same variable? Well, they refer to two separate boxes. Therefore, they are not the same variable. Next, we look at the linking statement between these two. It is twice. What the heck does that mean? So we look back at our dictionary and we see that is means equal sign, twice means 2 times. Now, the 2 times is affecting something. In this case, it's affecting the number of toys in box 2. So it's 2 times Y, quite literally. And we can come to the conclusion that our statement is X equals 2 times Y. Let's take a look at the third statement here. Jim's number of shells is 3 more than twice Aaron's number of shells. What are our variables in this case? The first variable is Jim's number of shells, which I'm going to call X. The second variable in this statement is Aaron's number of shells, which I'm going to call Y. Now, what is the linking statement between these two? So we have is 3 more than twice. There's actually 2 linking statements here. Is 3 more? So 3 more than. And then there's then twice. So there's actually 2 different operations here. Is 3 more than, so it's plus 3, then twice times 2. So times 2. So we have plus 3 and then times 2. But the times 2 is actually affecting Aaron's number of shells. And we have 3 more means plus 3. So this translates to this particular statement. So we have X is equal to plus 3 plus 2 times Y, because it's twice Aaron's number of shells. So when we were to massage this, we get X equals to 2Y plus 3. And that's how we represent this statement into an equation. There are vastly large numbers of statements you can try to translate into equations. But the most important thing to really get better at this is, first, remember the dictionaries of buzzwords, and second, it takes a lot of practice. You won't be able to get them overnight, unless you're a bloody genius, of course. And it takes a lot of recognition. It takes a lot of practice. So make sure to use the dictionary and practice a lot to make sure that you understand how to translate these words into equations, as this will be really important in the next video. This concludes the video for translating words into equations. If you have any suggestions or comments, feel free to write them below. You can also press the subscribe button if you really like my video. You can also email me at waymanquant87@gmail.com. Thanks for watching, and I hope to see you again next time.